The Atlantic Ocean has a way of hiding its greatest dangers. For days, sometimes weeks, the water can appear calm. Satellites detect only clusters of ordinary thunderstorms drifting west from Africa. Nothing about them suggests that history is about to change. But every once in a while, the atmosphere aligns perfectly. Warm ocean water, light upper-level winds, and a powerful tropical wave come together to create something far more dangerous than anyone expects. In September 1989, those ingredients produced a hurricane that would rewrite emergency planning across the eastern United States. Not because it was simply strong, but because it refused to behave like hurricanes normally do. Thousands of families believed they were safe. Entire communities followed evacuation orders exactly as instructed. Officials trusted maps that had been approved by experts. Yet before the night was over, those assumptions would be washed away by one of the most destructive storms America had ever experienced. This is the story of Hurricane Hugo. A storm that proved nature doesn't care about predictions. The story begins nearly 2 weeks before landfall. On September 9th, a tropical disturbance rolled off the western coast of Africa, blending into dozens of similar weather systems that leave the continent every hurricane season. Most disappear over the Atlantic without attracting much attention. This one didn't. As it crossed the unusually warm tropical Atlantic, thunderstorms organized around a strengthening center of circulation. Within days it became Tropical Storm Hugo. Meteorologists immediately noticed favorable conditions ahead. The ocean was exceptionally warm. Upper-level winds remained weak. Nothing stood in the storm's path. Each passing hour allowed Hugo to grow stronger. By the middle of September, it had intensified into a major hurricane. From space, the storm looked almost perfectly symmetrical, a classic sign of a powerful cyclone operating at maximum efficiency. Its eye became sharply defined. Massive bands of thunderstorms spiraled hundreds of miles across the Atlantic. The storm was no longer just another hurricane. It was becoming one of the strongest systems of the entire season. The first populated islands to face Hugo were in the northeastern Caribbean. Residents had only a short time to prepare. Windows were covered with plywood. Fishing boats were pulled onto shore. Supermarket shelves emptied within hours. Emergency shelters filled quickly. Many people had experienced hurricanes before. Few imagined this one would be different. They were wrong. When Hugo reached islands like Guadeloupe, its violent eyewall arrived in darkness. Wind speeds exceeded 140 miles per hour. Buildings shook violently. Concrete walls cracked. Roofs disappeared into the night. Palm trees snapped like matchsticks. Power failed almost immediately, leaving entire communities in complete darkness except for flashes of lightning inside the storm itself. By sunrise, neighborhoods that had existed for generations had been transformed into fields of broken timber and twisted metal. Roads vanished beneath fallen trees. Communication systems collapsed. Rescue crews struggled to reach isolated communities. For many Caribbean islands, Hugo became one of the worst natural disasters in their history. But the hurricane wasn't finished. Instead of weakening significantly after crossing the islands, Hugo maintained remarkable strength as it pushed toward the Virgin Islands. The island of St. Croix suffered catastrophic damage. Entire residential areas were devastated. Critical infrastructure failed. Hospitals operated under emergency conditions. Many survivors later described the experience as sounding like continuous explosions lasting for hours. Even reinforced buildings struggled against the relentless wind. Puerto Rico soon found itself directly in Hugo's path. Although the eye passed just offshore in many areas, hurricane-force winds covered a vast region. Forests were stripped bare. Electrical transmission lines collapsed. Floodwaters cut off entire communities. Weather instruments struggled to measure the hurricane's true intensity. One ship anchored near the region reportedly recorded wind gusts approaching 170 miles per hour before its equipment failed. The readings highlighted just how powerful Hugo had become. And there was an even bigger problem. The hurricane was now entering open water once again. As emergency managers across the Caribbean assessed overwhelming destruction, forecasters in the United States focused on a different question. Where would Hugo go next? Computer models increasingly pointed toward the southeastern coast. South Carolina emerged as the most likely target. For many longtime residents, memories of earlier hurricanes immediately resurfaced. But Hugo appeared capable of becoming something even more dangerous. Television stations interrupted regular programming with continuous weather coverage. Emergency bulletins urged residents along the coast to begin preparations immediately. Officials warned that delaying evacuation could become life-threatening. Unlike inland storms, hurricanes offer only a limited escape window. Once tropical storm force winds arrive, emergency vehicles can no longer respond safely. Anyone remaining behind becomes isolated. State leaders didn't want to take that chance. Mandatory evacuation orders spread across coastal South Carolina. Hundreds of thousands of people packed their belongings and headed inland. Traffic stretched for miles. Gas stations filled with long lines. Hotels far from the coast quickly sold out. Entire highways became rivers of vehicles moving away from the Atlantic. Historic Charleston, with its centuries-old buildings and narrow streets, transformed almost overnight. Storefronts disappeared behind plywood. Construction crews secured cranes. Homeowners nailed boards across windows that had survived generations of storms. The city braced for impact. Meanwhile, in the small fishing community of McClellanville, residents followed official instructions exactly as planned. Emergency studies had identified Lincoln High School as one of the safest hurricane shelters in the region. According to government flood maps, the building sat comfortably above expected storm surge levels, even during an intense Category 4 hurricane. Families trusted those conclusions. Parents carried blankets and supplies inside. Children settled into classrooms converted into sleeping areas. Volunteers distributed food and drinking water. More than 1,000 people gathered inside the school, believing it offered the highest level of protection available. Among them were emergency medical workers assigned to assist throughout the night. They expected injuries from flying debris, power outages, minor medical emergencies. No one anticipated that the shelter itself would soon face unimaginable danger. Ironically, there was one small reason for optimism. As Hugo approached the American coastline, it briefly weakened. Forecast discussions suggested the hurricane had lost some of its earlier intensity. Many hoped the trend would continue until landfall. If the storm continued weakening, the worst-case scenario might be avoided. But hurricanes are living systems. And sometimes they find fresh energy exactly when it matters most. Just offshore of the southeastern United States flows one of the most powerful ocean currents on Earth, the Gulf Stream. Its warm waters act like high-octane fuel for tropical cyclones. As Hugo crossed directly over this current, something dramatic began to happen. Pressure inside the storm dropped. Thunderstorms intensified. The eye wall reorganized. Wind speeds climbed once again. Hour by hour, Hugo grew stronger. By sunset on September 21st, the hurricane had regained Category 4 intensity. Instead of arriving weaker, it was approaching the coast with renewed power. And it wasn't slowing down. The storm accelerated towards South Carolina faster than many hurricanes before it. That forward speed would become one of the defining reasons Hugo proved so destructive, not only along the shoreline, but hundreds of miles inland. Few people realized it yet. The worst was still offshore.